If moving data from CAD to GIS is a challenge, then translating the same data back again would make anyone cry. But with FME, there's no need to panic. Your data can make a return trip via a GIS application without losing any of its CAD-specific components or geometry.
Life's so much simpler when your CAD and GIS applications are truly interoperable, and FME can make this dream a reality. It translates between 300 or more different spatial data formats, and its translations are reliable and they won't compromise your data. Let's see it in action.
With FME, the process starts by identifying the CAD data to be converted and the GIS format it's required in. The formats can be one of the many CAD, GIS, database, and other formats supported by FME. In this case, the conversion is from a MicroStation design file, a common CAD format. The data is being moved to a PostGIS spatial database. However, the exact same techniques apply to any format of CAD and GIS data, including AutoCAD, ArcGIS, Oracle, SQL Server, and MapInfo. Fundamentally, FME is a visual tool. The source CAD data gets analyzed, and a graphic representation of the translation is created. FME's rich data model will ensure that none of the source data structures or geometries are lost in translation. But FME also supports user-defined transformation of the data, both contents and structure. It is this capability that allows data to pass unscathed by conversion to GIS and back. The user can edit the structure of the outgoing GIS data to record all the individual CAD components that are normally not retained in the GIS dataset, for example a block or a cell name, or even basic symbology like line style and line color. In this example, information about cells is being stored, so those elements can be reconstructed when the data is written back to the CAD dataset. The translation can be run very easily at the click of a button, and the output data made available to be processed, analyzed, and updated by a GIS application, either desktop or mobile. Once the GIS user is finished with the data, it can be translated back to CAD, again using FME. This time, the FME translation is designed to make use of the stored information in order to recreate exactly the geometries and data structures of the original data. This example uses FME transformers. Because there are over 400 different transformers, FME is a very powerful data manipulation tool and can simultaneously carry out multiple processes on the data. For example, QA tests can be carried out, and failed features passed back to the GIS application for cleanup, or a set of metadata records can be written to document whatever changes have taken place. Because the translation model can be saved for future use, it is very simple to run it again and again, maybe even automating the process. The output now looks like this. It contains all of the original CAD data and the same specification as before, but with GIS updates. To recap, FME is the perfect tool for professionals transferring spatial data to and from CAD. It is powerful, intuitive, and comprehensive. You can try it for yourself by downloading a free trial from www.safe.com.